Welcome back, dear students. Let's continue with exercise 20C, and this video is going to be the last video on exercise 20C. Right, so let's see the first question. So question says, the area of a trapezium is 279 square centimeter and the distance between its parallel sides is 18 centimeter. So for the explanation, let me draw a rough diagram for you. So this is a trapezium, let's say. Okay, so this is a trapezium for you, and it is given that, so you know, the parallel sides are represented as A and B. Okay, and the distance between them. Okay, so this distance is represented as H. All of you know that, right? So for this trapezium, your area will be, formula for area will be half into A plus B into H. All of you know this, right? Okay, so here it is given that this area, okay, so this area is equals to how much? It is 279 centimeters square, okay, and the distance between the parallel sides, that is this height, let's say height H is given to be 18 centimeter. Okay, now if one of the parallel side is longer than the other side by 5 centimeter, that means if this is 5, this has to be 10. If this is 10, this has to be 15. Basically, this longer side is 5 centimeter longer than the shorter one. So you need to find the length of the parallel sides. So what we will do is we will take this to be x centimeter, okay, and automatically this becomes 5 centimeter more. That is, it becomes x plus 5 centimeter. Is that clear? So that's why let me write, let A equals to x centimeter and B equals to x plus 5 centimeter. Okay, now given is H, that is distance between A and B, is given to be 18 centimeter, right? And you have area is given to be 279 centimeters square. Now in place of area, let me write half into A plus B into H. Okay, so we have this equals to 279. You know, half into A plus B into H is also area, right? So let's put the value now. So we have half. Okay, so what is A? A is given to be x plus B is x plus 5. B is x plus 5, and we have into H, which is H is 18, is equals to 279. Now look at this carefully. Here 2 and 18 gets cancelled, so you have 9 here. So here what will I get is, now open the bracket and bring this 9 over here first and foremost. Okay, so it becomes 279 by 9. If you bring this 9 over here, now here you have x plus, now open the bracket, you get x plus 5. Okay, now see here carefully. Again we will do the cancellation. So 9 ones are 9, 9 threes are 27, 9 ones are 9. So basically it is 31 by 1 is 31. So now we get x plus x is 2x. So bring this 5 over here, it becomes 31 minus 5, which is 26. So from here, if you find what is x, the value of x turns out to be 26 by this 2 goes over here, and when you do the cancellation, it turns out to be 13. Okay, so we got the value of x. So therefore the lengths of the parallel sides, that is A and B. Okay, that's what the question is asking you to find. So therefore A is equals to x centimeter, which is x is 13, so it becomes 13 centimeter, and B is x plus 5, that is 13 plus 5 centimeter, which is equals to 13 plus 5 is 18 centimeter. So these two are your answer for this particular question, right? So you may pause the video and note down your solution. Let's move to next question now. So we have next question which says the area of a rhombus is equal to area of the triangle. Okay, so whatever is given, let me just write down. So given is area of the rhombus is equals to area of the triangle. Okay, so area of the rhombus is given to be area of the triangle. Now, you know area formula for rhombus is half into product of the diagonals. So let's say D1 and D2 are the two diagonals. So D1 into D2 is equals to half into, now area of triangle is half into base into height, right? So it is half into base into height. Okay, right. So what are the things given? Let's see. Now, if the base of the triangle is 24 centimeter, so base is given, its corresponding altitude, that is the height, is given to be 16 centimeter. That is, we have half into base is given to be 24, and the height, that is altitude, is given to be 16. Okay, and one of the diagonals of the rhombus is 19.2 centimeter. Find its other diagonal. So see, we have got two diagonals, D1 and D2. One of the diagonal is given, which is 19.2. So we have half into, let's say D1 is 19.2. Okay, into we have D2. So D2 gives me the length of the other diagonal, and that's what we need to find here. Okay, so what you can do here is you can directly cancel half and half here. Okay, so what you can do is you can write this 19.2 as 192 by 10 into D2. So we have 24 into 16 out here. So keep D2 here. So this 10 goes up, so it becomes 24 into 16 into 10. Okay, and divided by this 192 comes to the denominator. Okay, so when you simplify this, when you do the cancellation, you find that this turns out to be exactly equals to 20. Okay, so this will turn out to be exactly 20. So therefore we say D2 is 20 means what? This is the other diagonal, yes. So therefore the other diagonal is is 20. So what is the unit we are using so far? The unit we are using is centimeter. Okay, so this will be your answer for this particular case. So you may pause the video and note down your solution. Let's move to next question now. So next question says, find the area of a trapezium ABCD in which AB is parallel to DC. Okay, so first and foremost, let's draw the diagram. So diagram says AB and DC are parallel. So let's quickly draw two parallel lines. Okay, just wait a minute. This is not parallel, right? So I'm drawing a parallel. Oh, I'm sorry. I'm drawing a pair of parallel lines. Right. So these two look somewhat parallel. Okay. So it is given that AB and DC are parallel, and also angle B and angle C are 90 degree. Okay. So we'll construct 90 degree also. So we can construct 90 degree angle this way. Right. Okay. So this is also 90 degree. Now just join the rest of the part. Okay, so that's what is given to us. So basically here what is given is, see, first and foremost let's write B and C here. Okay, so this is angle B, let's say. So this is my angle B, and this is my angle C, which is given to be 90 degree each, and we can see from the figure also. Okay, so you can write A here and you can write D here. Okay, so it is given AB is 18 centimeter, AB is 18 centimeter, angle B and angle C both are given to be 90 degree, we have noted down. CD is given to be 12 centimeter and AD is given to be 10 centimeter. Okay, so you need to find the area of this particular trapezium. So before I find the area, what will I do is I'll do a small construction. Okay, so the construction is I'll draw a perpendicular line like this. Okay, and what will I do is I'll call this point to be point D. Okay, E, let me call this point to be point E. Okay, now see, this is my extra construction. So construction is draw a perpendicular. This means perpendicular. Draw a perpendicular from D to AB at point E. Okay, so that's what is the construction. Therefore, we have, now see here carefully, very carefully. Okay, now you know AB. Okay, so you know the length of AB. Okay, now what is this EB going to be? So EB is going to be equals to, the value of this EB is going to be equals to DC, isn't it? Because this is a rectangle now. So EB is going to be equals to DC, which is equal to, DC is how much? DC is given to be 12 centimeter. Okay, so therefore now let's try to find how much is AE. Okay, now can I write AE as, see, we have AB, so from AB just remove EB. Okay, so from AB I am going to remove EB. Okay, so now we have, what is AB? Length of AB is given to be 18, right? And what is EB? EB is 12, right? So EB is 12. So that's why this turns out to be how much? This turns out to be 6 centimeter. That is, the length of this is 6 centimeter. Okay, and also remember this is also 90 degree because this is the perpendicular. Okay, so that's why this becomes a right angled triangle now. Okay, so therefore in triangle we have AED, in triangle AED. So you know, by Pythagoras theorem, so we have hypotenuse is AD, so we have AD square is equals to AE square plus DE square. Okay, now let's simplify this. AD is given to be 10, so it becomes 10 square is equals to AE is 6, so it becomes 6 square plus DE we don't know. Okay, so why am I finding DE? Because DE is the height, because for finding area you need height also, right? So that's what I am trying to find here. Okay, so we have from here, see here carefully, so this becomes 100, this is 36 plus this is DE square. So from here we see that DE square will be 100 minus 36, which is 64. So therefore the value of DE turns out to be root over 64, which is 8 centimeter. Okay, so therefore now question is asking you to find area of the trapezium, right? So area of the trapezium, all of you know the formula is half into A plus B into H. Now half into A and B represents the parallel sides. Here we have the parallel sides are DC and AB, right? So can I write as AB plus DC? Yes, and you know height is DE. Okay, DE represents the height. So we have half into AB is given to be 18 plus DC is 12 and DE, just now we found this to be 8. Okay, so 2 ones are 2, 2 4s are 8. Now we have 18 plus 12 is 30 into we have 4. So when you multiply these two, your answer turns out to be 120 centimeter square. So that's why your area of this particular trapezium turns out to be 120 centimeter square, right? So you may pause the video and note down your solution, and with this we close exercise 20C. Thank you very much.